This is Mod 6 Lesson 1 homework. Okay. This says the graph shows Lucy's trip to Sydney's house and then back home. See, this is the distance from home. Which part of the graph shows her distance from home increasing the fastest? Okay, she's increasing here, not increasing here, decreasing there. So the one that increases the fastest is 1. Tiana ran in her first track meet. She ran at a constant speed for the entire race. Which sketch best illustrates Tiana's run? Constant speed means that you are talking about a linear equation, okay? If we're talking about a constant speed here, oops, let's see if we can grab that one. Then this would be it. The total distance she runs is going up at a constant speed. It's linear. Here it would be going down. The distance she ran would be going down. If she's running, as more she runs in time, it's going to go up. It's going to be an increasing function. This third one. Which graph shows a function that's increasing continuously as x increases? Well, this is decreasing, so it's going down. It's not increasing. This one is increasing continuously, right? This one increases here, but it decreases there. So it's not increasing continuously. This one's decreasing here and increasing there. So it's not increasing continuously. This is the only one right here, the linear one that's going up. Which is a graph of a function that is nonlinear for x is less than 2 and is increasing linear for x greater than or equal to 2. Okay, so we're talking about what happens at 2. Nonlinear to 2 and then is increasing. No, it's decreasing. Nonlinear to 2 and then increasing linear after 2. And that's not, let's see. Nonlinear to 2, but then it's decreasing. Nonlinear to 2, but then it is linear. Okay, this is the one we're talking about. Four graphs are shown below. Decide whether each is linear or nonlinear, increasing or decreasing from x is 0 to 4. Okay, nonlinear, let's say from 0 to 4, it's increasing, right? Here's 0, there's 4. It's increasing. Nonlinear, what's it doing from 0 to 4? It's increasing, going up. This one's linear. What's it doing from 0 to 4? It's linear, right? This one's linear. What's it doing? This one's not increasing or decreasing, right? This one's linear. From 0 to 4, it's decreasing. The value of a linear function when x is 0 is 4. The value of a linear function when x is 0. So when x is 0 is 4. So you'd start at 4. Okay. Further, for each 2-unit increase in the value of x, each time you go up 2 on x, the value of y decreases by 3. So over 2 on x, then down 3 on y. Okay? That would be your function right there. Caleb is participating in a walkathon. His goal is to walk as far as possible over 8 hours. Okay? For the first 3 hours, he keeps a steady pace of 2 miles per hour. So let's try that. 3 hours, he's going 2 miles per hour. So the first hour, he goes 2 miles. Let me get this. Over the first hour, he goes 2 miles. Over the second hour, he goes another 2 miles. The third hour, he's going another 2 miles. Okay. Then let's see what he's got after that. He then stops walking while he takes a 1-hour lunch break. Okay, so let's go back down. So for the next hour, he takes a lunch break and he doesn't walk, does he? Okay, so his distance is not going to increase any, will it? Okay, and then let's see what's going to happen then. Finally, he walks at a steady pace of 1 mile per hour for the remaining time. Okay, so it's going to be a total of 8 hours. He's going 1 mile per hour after that. For each hour he goes over, he goes up 1 mile, right? Over, up 1 mile, over, up 1 mile, over, up 1 mile. There we go. There's our function. Consider the function f of x, graph below. F of x just means the function in regards to x. Each inequality represents a range of x values over which the function is defined. Drag and drop the correct statement into each box. Is it increasing, decreasing, or constant? Okay, as long as x is less than -1, this part here, it's going up, so it's increasing. For x -1 to 3, it's increasing. For x 3 to 8, it's decreasing. For x 8 above 8, it's increasing. Ivan's position on a Ferris wheel is represented by the graph below, where x is time in seconds and y is distance from the ground. Which interpretations of the graphs are true? Choose all that are correct. Ivan's position changes from increasing to decreasing at a little over 6 seconds. So he's increasing here, and at 6 seconds, he starts going down, right? This is true. Ivan's starting position is 2 feet off the ground. Yep, the initial value is 2. The Ferris wheel stops when Ivan is 10 feet from the ground. Well, it stops here, right? And he is what? 10 feet from the ground. The relationship between time and Ivan's position at 10.2 seconds to 12 seconds is nonlinear. No, that's linear, isn't it? Okay, that looks like a line. The change in Ivan's position is linear from 0 to 10.2 seconds. Nope. See, it's going up and down. Nope, not linear. The graph shows how the height of a balloon is changing over time. Which quantity is given by the slope of the line on the graph? Well, we know when we're talking about slope, it is change in y over change in h. So that is change in height over time. Okay, height over time, and if it's going up, that means it's getting higher over time. So what it's showing us is the rate at which the balloon is rising. The slope tells us the rate at which the balloon is rising. The graph shows how the weight of the water in a plastic jug depends on the amount of water in the jug. Which statement best describes the meaning of the slope of the line on the graph? Well, let's see. This is the weight of the water based per gallons, right? Number of pounds per gallon. So what do we have? We've got, when we've got 10 gallons, it's 80 pounds. So 80 pounds per 10 gallons, right? That would be 8 pounds per 1 gallon, or 80 pounds per 10 gallons. Let's write it over here so we see it. Let's pick this point right here, and this gives me 80 pounds per 10 gallons, okay? So that would be 8 pounds per 1 gallon, right? Okay. 10 gallons weighs 80 pounds. Well, that's true, okay? But we're talking about the slope, okay? Water weighs 1/8 of a pound per gallon. No, it weighs 8 pounds per gallon. Water weighs 8 pounds per gallon. That's the slope. That's what the slope thinks. James is making omelets for his family. He begins with a dozen eggs, and each omelet takes 2 eggs. Which graph shows the number of eggs left based on the number of omelets made? Okay, let's see. Each omelet he makes takes 2 eggs, right? So if he starts out and, let's see, he makes 0, it's there. When he makes 1 omelet, he's used 2 eggs, but he's talking about the number of eggs left. So we're going to talk about, we start out here and we make 1 omelet and we use 2 eggs, right? Another omelet, we use 2 eggs. Another omelet, we use 2 eggs, right? Okay, this is the graph you're talking about. "14 says, which scenario is modeled by this graph? Joe ran a 25-foot sprint at a constant rate. No, there's no constant here. This is a linear. This is a nonlinear. Sue released a helium balloon into the air. It rose until it was 25 feet in the air. That makes sense. Then popped. Okay, then it would come down. All right. I don't know. Popped would come straight down, wouldn't it? Liz dove off a 5-foot high diving board. No, there's nothing about starting at a 5-foot high diving board. Ken threw a ball 25 feet in the air. Okay, so he throws it up 25 feet. It lands on the roof 5 feet off the ground. That makes sense right there. Okay, that's where that one would be. And then this last one here. No, I'm sorry, there's 2 more. At what time does the rocket hit? The following graph shows the height of a toy rocket above the ground over time. At what time does the rocket's height begin to decrease? Well, it goes up, 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 and this is where it starts to decrease. This is at 5 seconds, isn't it? And then this last one. The graph shows Rita's trip to school and then back home. Rita walked from her home to the bus stop. Here she is walking. From there, she took the bus to school. Here she is taking the bus. She spent most of her day at school. There she spends her day at school. Finally, she took the bus straight home. Which part of the graph shows her distance from home decreasing? Here's your distance from home. This is the only one where the distance from home is decreasing. That's number 4. Okay? And that covers that homework assignment.